Okay, so next let us discuss, before we start, the exercise 8.1. Okay, this is absolutely important, so let us write it together. Pythagoras Theorem. Okay, Pythagoras Theorem. Okay, so what does it say? Write along with me. States that in a right triangle, the square on the hypotenuse, is equal to the sum of the squares on the other two sides. So this is the statement of the Pythagoras theorem. So this is saying that in a right triangle, that means Pythagoras theorem is applicable only for a right triangle. So we need to understand the Pythagoras theorem clearly first. So let us take a triangle, and the triangle must be right triangle. So what is a right triangle? Now we know that every triangle has three sides. For example, if you were to label this as ABC, this triangle, then the three sides are AB, BC, and AC or CA. And then it has three angles: angle A, this one; angle C, this one; angle B. So out of the three angles in the triangle, if one angle is 90 degree, so 90 degree sine is this one, okay, then that triangle is called a right triangle, meaning this triangle ABC we have drawn here right now is a right triangle. So one side in the right triangle is there called hypotenuse. Hypotenuse is found only in a right triangle. So which one is the one out of the three sides, AB, BC, and AC, which of these three sides is the hypotenuse? We need to identify that. So how do you do that? Now, before we go there, let me draw a figure here. Two lines are meeting at the same point here. Let us say AB and CB are meeting here, meeting point B. So such a figure formed by two lines meeting at a point is called an angle. So the figure here, right here, is an angle. So when we look at this, we see that the angle has two arms, BA and BC. Just like we human beings have two arms, an angle has two arms. It has only two arms, okay, not more than two and not less than two. So the two arms of this angle are, this angle is here. The meeting point is called the vertex, okay. So when we write this angle, we have to write A and BC. Means the meeting point should come in the middle position, and A and C are on the outside. Or you can write the same angle as C, B, A. Both are correct. As long as the vertex, the meeting point of the two arms, which is B, is in the middle position, then that is correct. So this angle is angle A, or we can say angle B, A, C, making sure A is in the middle, or C, A, B. Likewise, this angle is angle A, B, C, or C, B, A, with B in the middle. And this angle here at the point C should be B, C, A, or A, angle A, C, B. The vertex should always be in the middle position, okay. We just call this angle as angle B simply, but if you were to write complete, then angle A, B, C, meaning this point should be in the middle. Or we can also write it as C, BA. All these three are correct. To express this angle, we can express in these three ways. Okay. Now, since just now we said every angle has two arms, this angle B, which is 90 degree, has two arms. So let us find out what are the two arms of this angle B. They are BA and BC. Right. So the triangle has three sides: BA, BC, CA, or AC. So the two sides of the triangle that make the arms of this angle B are angle B 90 degree are BA and BC. Then which side doesn't make the arm of this angle? Yes, that's right. AC is not the arm of the 90 degree angle B. That one is called the hypotenuse. So hypotenuse in the right triangle is the side of the right triangle which doesn't form the arm of the 90 degree. Okay, so BA and BC are the arms. Since AC is not the arm, AC is the hypotenuse. So very important to spot and identify that hypotenuse first, because as you see, now let us read. States that in our right triangle, the square on the hypotenuse. So we now know AC is the hypotenuse, so we write here square on the hypotenuse means AC square. Right, the theorem is this one we're writing. Is equal, next two words means equal sign, double dash. To the sum means it is added, plus the word sum means it is added, of the squares on the other two sides. So the remaining hypotenuse is already taken, AC square. The remaining two sides are AB or BA, and BC or CB. So we write here AB square plus BC square. The square on the hypotenuse is equal to the square of the remaining two sides, means AB square plus BC square. So this is called Pythagoras theorem. Okay. So you have completed writing. Now let us see how we can apply Pythagoras theorem in one way. So there are three cases. So you can just try how to apply this theorem, means Pythagoras theorem. So let us answer this question by, there can be a case here, case 1. Let us say, same right triangle you draw. Then right triangle means one angle is 90 degree. So let us draw that 90 degree here. Let us say A, B, and C. So this is a right triangle because one angle is 90 degree. The two arms of the 90 degree are BA and BC. So AC, which is not the arm, is the hypotenuse. Be clear. Let us say these two sides are given. Let us say AB is 3 centimeter. This BC length is 4 centimeter. So in this triangle, out of the three sides, two sides are known to us, AB and BC. So the unknown, which is the unknown side? Yes, hypotenuse. The SC, which is the hypotenuse, the value is not known to us. So one application of Pythagoras theorem is, in a right triangle, if two sides are known or given to us, we can find the third unknown side by using Pythagoras theorem. Case 1, like we want to find hypotenuse, then we apply the basic theorem, hypotenuse square is equal to this square plus this square, just like we did just now, AB square plus BC square. So you can write here, okay, wait, you can write like this. So how can you find this unknown side AC? By using Pythagoras theorem. Using Pythagoras theorem, let us find this unknown side, which is the hypotenuse square, is always equal to. So if you are finding the hypotenuse, it will be the remaining two sides given, AB square plus BC square. We have to add if we are finding the hypotenuse, which is unknown. Okay, then that implies, example we are solving, you can write along with it. AB is the figure 3 centimeter square, so 3 square plus BC 4 square, right? So now if you remove this square from here, AC, then we know root will come on the right side. right? So 3 square is 3 3s are 9 plus 4 square, 4 4s are 4 square means 4 into 4, so 4 4s are 16. So that will be equal to root over 9 plus 16 is simply 25, right? And we know 25 is 5 5s are same, 25. And when two identical numbers are inside the root, we can take it out as single, and the root is therefore removed. So we found the unknown side AC as 5 centimeters. That's how we use Pythagoras theorem to find the third unknown side, case 1. Let us take case 2. Let me take it here. Okay, case 2. So in the case 2, let us say there is triangle is given, very similar to the first but slightly different. Same triangle is given, let us say. This time this is given, let us say 4 centimeters, same thing. And these two arms of the 90 degree are BC, BA and BC. This is the hypotenuse. Hypotenuse is also given, let us say 5 centimeters. So this is not unknown. Now the unknown side is AB, which is not the hypotenuse. So when we are finding the hypotenuse, it is AB square plus BC square, the two sides added squares, right? But here the unknown side, so using Pythagoras theorem, we want to find out the third unknown side, because one use of Pythagoras theorem is to find the unknown side in the triangle. If two sides are known, easily we can find the third unknown side by using Pythagoras theorem. So unknown side is now AB square equal to, now this is clearly not the hypotenuse. So when you're finding a side which is unknown, which is not a hypotenuse, then our equation must be, we always write the hypotenuse first, AC square, this hypotenuse C, minus the known side here, BC square, AC square minus BC square, not BC square minus AC square, not hypotenuse should be written first, square minus, keep that in mind, okay. Then we write here AB square is equal to, AC is now 5 square minus BC is here 4 square, right? And we can continue and write it as, that implies AB, if you were to write like that, then root will come here. Square removed means root will come on the right side. Now, in our lower classes also we did, there's one formula which says here, A square minus B square equal to A plus B into A minus B. Let us apply that formula. So here, A square minus B square is, A is 5, so 5 plus 4, A plus B into A minus B, 5 minus 4. So that will be equal to root over 5 plus 4 is, yes, 9. 5 minus 4 is plus 1. So root over 9 ones are 9 is root 9, right? So root 9 means here 3 3s are 9, so it will come out as a single 3. So we found the unknown side AB by as 3 centimeters. Now it's known by using Pythagoras theorem. One use of Pythagoras theorem, as I said, is in a right triangle, if two known sides are known to us, then we can find easily the third unknown side by using Pythagoras theorem. And if that unknown side is like something like AB, which is not the hypotenuse, then it should be hypotenuse square minus the known other side BC square. Now another case is possible, so let us take that case 3. Case 1 is the hypotenuse unknown, so it will be plus AB square, the sum of the squares of the two known sides, AB square plus BC square. Case 3, let us take. Case 3 is, let us say, we have a triangle here, right triangle again, A, B, C. Let us say this time we know 3 centimeters and hypotenuse, the two arms of the 90 degree are BA and BC. So the one which is not the arm is the hypotenuse, which is AC. Hypotenuse is also known to us, 5 centimeters, let us say. So now this time BC is unknown to us. Here AB is unknown, now BC. So it will be same to the case 2, that is using Pythagoras theorem, to find the third unknown side. So if two sides are known, 5 cm and 3 cm, we can find the unknown side BC by using Pythagoras theorem. So BC squared, the unknown we keep on the left, is equal to, then since BC is not hypotenuse, just like AB is also not hypotenuse, it will be very similar to this. Just like that, hypotenuse first here, AC square, then minus, like this, minus. Then the known one, AB square, AC square, hypotenuse, known, 5, 3. So that implies BC will be, square root means root over, AC here is 5, so 5 square, minus AB is here, 3 square, right? So apply that A square minus B square formula again, then A plus B into 5 is A minus B is 3, then root over 5 plus 3 is 8, right? And 5 minus 3 is 2. So we can just do it like this to keep it simple. So root over 8 2s are 16, and we know 16 is 4 2 times. So the double 4 will come out as, simply you can just write directly 4 centimeter. Okay, so the 3 cases. Just to sum up the case 1, 2, and 3, let us do like this once. Finally, so that is how you apply the Pythagoras theorem. Now look here. So here, you can write along with me finally once more, revision. A, B, C. How do I apply Pythagoras theorem? So here, just write your revision, or you are revising, let us say. So let us say the unknown side is, okay, the two arms of the 90 degree are B, A, and BC. So the unknown side is, the two arms of the 90 degree are B and BC. So the SC, which is not the arm of 90 degrees, is the hypotenuse. So case 1 is hypotenuse is unknown. This is known, this is known. This we know, AB we know, BC we know, hypotenuse we don't know. Then how do we apply Pythagoras theorem? AC square equal to AB square plus BC square. This is what we will use. Okay, if this SC is the unknown, or you can also write BC square plus AB square, doesn't matter in plus. Then the next case is, let us say we have here ABC. Okay, so tick means we know. So here let us have a right triangle again, A, B, C. This time we know the hypotenuse and we know BC also. We want to find unknown AB, which is not the hypotenuse. The hypotenuse is clearly this one. Then what is the equation for this one? Unknown, keep it on the left, AB square. Then always write the hypotenuse first, AC square minus BC square. We are revising. Then the third case is possible is A, B, C. This is the hypotenuse we know by now. This is given to us, let us say. AB is also given to us, and we don't know BC. Since BC is not hypotenuse, the equation we'll use here is BC square equal to, just like this, writing the hypotenuse first. So here also BC, which is not the hypotenuse, so we write the hypotenuse first, AC square minus the known side here, AB square. And this is how we'll write the equation to find out BC. These are the 3 possible cases. Be very clear about this, okay? Because we'll be needing it constantly in this exercise 8.1. Okay, now next question. Next question is sine theta or cos theta, whatever is cosine theta, the product of sine and theta, the question is asking. If no, what is sine theta then? Let's see. Write the question like that along with me. And write the answer first, then we'll explain it. Now here, your answer is no. Sine theta is not the product of sine and theta. Then if it's not a product of sine and theta, what is sine theta? Then you write in the next paragraph, sine theta or tan theta or cot theta, same, is not two factors but a single symbol, okay, a single symbol denoting a particular trigonometric ratio, full stop. You can add this one. It is the ratio of the sine theta is opposite side. It is the ratio of the opposite side to the adjacent side. Oh, sorry, opposite side by hypotenuse side to the hypotenuse. It is the ratio of the opposite side to the hypotenuse of a triangle. That's it. That's enough. Okay. Now to explain this, what does this mean? This one you can just write it as for your own remembrance. Sine theta is not the product of sine into theta. That's what it means. Not multiplied. So what does that mean? It means this one. Suppose you have here sine theta equal to sine 30 degree. Okay. Then here some people do like this, cancel this one and write theta equal to 30 degree. And teacher is not so strict, so usually they don't cancel the marks, but strictly speaking this is wrong, because you see, when you write here 2 into x equal to 2 into 2, then 2 and x, here 2x equal to 2 into 2, then 2x is 2 into 2, 2x is the product of 2 and x. So we can cancel like this and we can write 2. This is correct because 2x is the product of 2 and x. But when we apply that to this here, sine theta cancel like this, it's wrong because sine and theta are not multiplied like 2 and x are multiplied here. So the right way, this is actually not the right way to do it. Okay, this whole thing is not the right way to operate it. Then how do we write in the right way? So if it is sine theta equal to 30 degree, sorry, sine theta equal to sine 30 degree, then we just by our imagination cover up both are same sine and sine, both sides there's equal sign. So by your imagination cover up the sine and the sine and just write here theta equal to 30 degree without cancelling it, because sine and theta are not multiplied, just as sine and 30 degree are not multiplied. In fact, sine and theta separated from each other is meaningless, has no meaning. Sine and 30 degree separated has no meaning. Okay, so that's what we discussed now. That is all that we'll discuss in this class. Okay.